This tutorial is going to cover the section on functions in Chapter 3, 3.1 and 3.2. And we're going to look at function operations and function compositions. So we're going to look at functions, and we're going to look at composition of functions and the operations with functions. So specifically, we're looking at 3.1 a little bit and 3.2 mainly in your Math 830 text. So I'm going to just do a few examples here, and we're going to just use two example functions. F of x is going to equal x plus 2 is our first function. And we're going to use another function, g of x is going to be represented as x squared. Of course, we can have a function meaning that one variable is related to another variable, so f of x is related to x, so it varies depending on what x is. Okay, and we're going to look at basically just a simple substitution. So what if you had something like f of negative 3? Well, that simply put is the function with negative 3 where x is. So negative 3 plus 2, which would equal negative 1. And that's the basics of function substitution. If we did the same here for g of negative 3, that would equal, well, negative 3 totally squared here, which would equal 9. Okay, so that's basic function substitution, something you've probably seen in the past. What we're going to look at is function operations. Now, function operations can be any of the basic four functions: addition, subtraction, multiplication, or division. And what we do there is we specifically look at using them as if it was normal algebra work. So what we're going to do here is we'll look at an example. Let's say we had f of x plus g of x. So there's an addition operation of two functions. So what we do is take f of x and add g of x. So if we simplified that in descending order here, x squared plus x plus 2. That would be our answer for that case. Similarly with multiplication or division. So if you had, let's say, 3 f of x, subtract 2g of x. Okay, so if you have a coefficient in front, you just treat it as if you were doing normal algebraic multiplication in this case here. So this would be like 3 times f of x. Notice the 3 does not go into where the x is because it's not inside the brackets. It's outside the brackets. Subtract 2 times what g of x is. So in this case, this would be 3x plus 6 minus 2x squared. So if I sort that descending order, 2x squared plus 3x plus 6. Okay, we're going to look now at maybe a multiplication or division example with numbers in it. What if you had something that looks like f of, let's say, negative 3 multiplied by g of, let's say, 2. Because the numbers are included inside the brackets, that means that number is substituted into the function. So what we do is we take f of x here first, which is x plus 2, and we put negative 3 in there, multiplied by g of x, which is x squared, but there's a 2 in there. So put 2 where the x is, it's squared. So this would be negative 1 times 4, which would equal negative 4. Okay. Let's take a look at a division example here. Okay, let's say I take f of negative 2 divided by g of 3. So in this case, we put negative 2 in there. Negative 2 plus 2 over 3 squared. Remember, the g of x is on the bottom, or x squared is on the bottom, so this would be 0 over 9, which is 0. Okay, now we're going to look specifically at composition examples. And what composition means is that you're taking one of the functions and substituting that value into the other function where x is. So I'm going to look, just to make sure this is in my field of view here. So composition. Now the basic way, there's a couple ways to write functions that are composed. Let's say f of x is equal to x plus 2 and g of x is equal to x squared. So let's go, f is a composition of g of x. So notice that the g of x is substituted where the x would be in the normal f of x function. So take your g of x function and substitute that into where the x is in the f of x function. So that would mean that x squared is substituted where x is. So x squared plus 2. Okay, take a look at the converse of that. If I had g and I had f of x in the brackets, what this would mean is that the f of x function is substituted where the x is in the g of x function. So the g of x is the outside function. So we take the x plus 2 square it and square it, because that's g of x. So this would actually give us a completely different answer, as you see, x squared plus 4x plus 4. So these two compositions, even though they use the two same functions, are completely different from each other. All right, so that's function composition. Let's take a look at function composition using some numbers in the case. What if I had f composes g of 1? Well, this specifically means that I take g of 1 first. So I can leave f there and take g of 1 first. So 1 squared is g of 1. So that's going to end up f of 1 squared is still 1. So when I get to this point, now I just take f of 1. So f of 1 is equal to x plus, so that would be 1 plus 2, which would equal 3. Let's take another look example here. Let's go g of, let's say f of 2. So g composes f of 2. So g, f of 2, let's do that now. So 2 plus 2, I'm using the f of x formula inside there because that's what I'm doing first. So that would give me g of 4. So now I must do g of 4. G of 4, let's just put an equal sign there. That's x squared, so that'd be 4 squared, which would equal 16. Okay, I'm going to do just one more here, a bit more of a complex example. Let's say we added in h of x is equal to, let's say, x squared plus x plus 2, and we still have our other two variables. So let's say I had h composes g, which composes f of x, or let's say f of 1. So I've got quite a bit of an inlay in there. So we have to start with the inside bracket and do f of 1 first. So h composes g and do f of 1. F of 1 is 1 plus 2. So that would be h composes g of 3. Okay, because that reduces down to 3. So now I would do g of 3. So I'm just going to move here. In case I'm out of the field of view, let me just quickly check here and slide that up a little bit. So this would give us g of 3 is what we do next. So that'd be h of, now do g of 3. So that'd be 3 squared. So this would be h of 9. And our final step then would just be take the h function and plug in 9. So that would be equal to 9 squared plus 9 plus 2. So 9 squared is 81 plus 9 plus 2. So this would be 92 total. And that's our tutorial on function composition and function operations for section 3.1 to 3.2.